Hey guys, welcome back. Welcome to Vedantu's JE channel, everyone. How are you all? Especially my students who are targeting JE next year, that is 2021, or in other words, people who are moving from 11th to 12th standard. So, guys, you are the new 12th standard students. So, I welcome you all specifically because this is the time of every day when we meet you all at 9 o'clock for our discussion for the topics which are related to JEE 2021. But nevertheless, if there are students from JEE 2020 batch, you guys are also welcome. I know 2022 students who are moving from 10th to 11th, maybe you will not be able to understand this topic at this point of time, but then 2020 Janta who are very close to their examination now, if you are interested in studying capacitor, then you are at the right time and at the right place because today we are starting the theory and understanding of capacitors. So yes, we are going to speak about capacitors in length and breadth. So stay tuned. But as I can see that a lot of the students have been coming new on our channel and maybe looking at me for the first time. So let me start off with my introduction, guys. Okay. So everyone, this is me, your Suri sir. I am a pass out and alumnus, you can say, of IIT Bombay, but more commonly now I'm known as Mugambo. Yes, guys, I'm called Mugambo is because when you will crack this examination of JEE in future, Mugambo push hoga. Okay, and if you are not aware about your teachers and the schedule that we follow over here at this point of time for people who are aspiring for JEE 2021, let me introduce your teachers to you all. This is Harsh sir, he is your chemistry teacher. This is Arvind sir, and he is your mathematics guru. And this is me, your Suri sir, and I try to teach you all physics. More importantly, guys, look at the timings. Every day, 9 p.m. is a very important time for all of you because this is the time, like right now, we discuss theory with respect to PCM for JEE 2021. And also on specific days at 8 p.m., we meet for discussion of only and only MCQs. So, guys, on Monday, you come for physics MCQs discussion with me. On Wednesday, you meet Harsh sir, and on Thursday, you meet Arvind sir. Okay, guys, so I'm sure you guys are aware about it. If you are not, then keep this timing noted and make sure that you have your cell phones reminders already set for these specific timings of the days which I have mentioned so that you are not missing out on any of our lectures. But then, guys, if you want even more dedicated preparation for JEE 2021, if you are a very serious aspirant for JEE 2021, then, guys, you can come to our platform as well on Vedantu by following this link. If you follow this link, guys, which is available in the description of this video, you know that at Vedantu's platform we have a batch dedicatedly running only for students who are aspiring for JEE 2021. So follow this link and enroll for free. Yes, free of cost enrollment is going on for this batch. Okay, here all these features are exclusively designed for students who are aspiring for JEE 2021. Okay, guys, so don't miss out on any of these things. Okay, moving on. Also, if you are new on the channel or have been coming for a while but haven't, then let me ask you to subscribe to the channel as well. And not just that, press the bell icon along with it so that you get the notifications whenever I come live. Okay, whenever I'm coming live or Harsh sir is coming live or Arvind sir is coming live. Okay, so that your preparations are always on track. So even when your schools are not running right now, when your classes may not be running, but then your preparation should not suffer. Okay, that's the objective with which we are here to help you all out. Okay, guys, so let's come back to the agenda. And as I said, today we are going to talk about capacitors and different types of capacitors. So guys, let's start. So before we get to the next slide, obviously the prerequisite is to have a basic understanding of electrostatics. Okay, so guys, what is the lesson plan? Today we are going to speak about the concept of capacitance, then we'll understand how a capacitor works or how it is formed, and then we are going to come to the various types of capacitors which happens around us, which we use as electrical devices around us. Okay, so let's start, guys. So the story starts with the idea of capacitance. Okay, so if I ask you that right now on the screen, what you see is basically a spherical conductor which has some charge capital Q given to it, and its radius is capital R. So guys, if I ask you, which we have already studied in the chapter of electrostatics, so I ask you, what is the potential of the spherical conductor? And when I ask this, obviously I mean to ask you the value of, or the expression of the capacitors, the expression of the potential for the sphere on its surface. What do you think is going to be the potential of this spherical conductor? Yes, yes, guys, you are right. The capacitance is going to be kQ by R. As you all remember, potential is a scalar quantity. It is basically the amount of work done in bringing a unit charge, a 1 coulomb charge from infinity to the surface of this spherical conductor. So this much amount of work has to be done by the external agent. Okay, but then our agenda is not to understand the potential over here, because that is the discussion that we have already done. Our agenda is actually to notice one thing, that if you see K is a constant and radius of this spherical conductor is also a constant. So in the hindsight, you can see that the potential of the conductor is actually related to the charge which is present on this conductor, or I can say that the potential is directly proportional to the charge. Can I say that? So if I keep on increasing the charge on this conductor, if I keep on bringing more and more and more charge on this conductor and start placing on the body of this conductor, or any shape or size of this body, then what will happen? The charge is going to increase, but along with that, the potential will also keep on rising. That simply means what? More and more charges are coming, they are basically becoming more and more unstable. Unstable, by that we mean the potential energy of the sphere is increasing, right? So when we look at this and try to look at it in this way, that we remove the proportionality, we introduce a constant over here, which is what we call as the capacitance. Which means what? This is something which is going to talk about, as the name suggests, the capacity of this body to be able to store charge on it. Okay, so this capital C that you see here, my dear friends, is basically the capacitance. So over here, say if I write K, obviously I'll write it as 1 upon 4 pi epsilon naught. R is already there, and a Q in the numerator. So if I take this 4 pi epsilon naught R to the right hand side, so to the left hand side here, then Q equal to this constant times V is basically, if compared with Q equal to CV, then what we get as the capacitance of this spherical conductor is 4 pi epsilon naught R, which is what we call as the capacitance of this conductor. Okay, so the equation that you see here is the idea of capacitance. Means what? What you have to keep in mind, guys, if I have to tell you this in very simple words, is that whenever the charge on any object will increase, the instability of the charge will increase. Because of that, the potential energy and hence the potential of that object is going to increase. So this is where the idea of capacitance comes into picture. Okay, let's talk more in detail about this thing. So when we try to generalize the previous idea of any to any conductor, we can say that for any conductor, if you will increase the charge, obviously the potential of that conductor will increase, and hence the equation, which is very important for this understanding, that Q will be equal to CV, or you can say that capacitance is going to be the ratio of the charge on the conductor with the potential of the conductor. But don't be mistaken, the capacitance may look like it is dependent on the charge and potential. It is practically not. But before that, let me tell you the definition, or the fundamental definition of the capacitance. So how do I define capacitance, guys? As you can see, capacitance is basically Q by V. So I can say that C will be equal to Q if V becomes 1. So like that only, capacitance is defined to be the charge that is required by the body to increase its potential by 1 unit or 1 volt. So if I want to increase the potential of every object on which I'm giving the charge, if I want to increase the potential of that object by 1 volt, then the amount of charge which will be required by that body for every rise in potential of 1 volt, that magnitude of charge will be magnitude wise or mathematically be equal to the capacitance of that body itself. Okay, so what type of quantity this is? So capacitance is basically a scalar quantity. As you can see on the right hand side, charge is a scalar quantity, potential is a scalar quantity. So definitely capacitance is going to be a scalar quantity. And if you think of it from a very layman's point of view also, capacitance is basically like talking about the capacity of any, say, water bottle. So capacity of a water bottle is something which you relate to the ability or the amount of water it can store. So the capacity is something which cannot be vector. It is something which is simply a scalar quantity. Also, something which is new for us, obviously what you see from here, that it is nothing but Coulomb per volt. So it is basically Coulomb per volt, which is what we are defining as Farad after the name of the scientist, obviously. So what exactly 1 farad is going to be? As you can see, 1 farad is nothing but the ratio of 1 coulomb with 1 volt. So it is basically the 1 coulomb charge. If it is able to raise the potential of a body by 1 volt, then the capacitance of the body is going to be 1 farad, which is actually a very big value. Okay, cool guys. I hope the idea is clear that capacitance is nothing but the ratio of Q by V. But guys, what is important is this discussion that capacitance is going to depend on various factors, but when we look at those factors, the most important of those factors is that it depends on the shape and the size of the conductor. If you remember when we were speaking about the first slide, the value of the capacitance of the spherical body, conducting body, came out to be 4 pi epsilon naught r. So what you see here, it is definitely not visibly dependent on the charge, it is not dependent on the potential, rather it is dependent upon r, which is depicting the shape and the size of the conductor that we were speaking about. Okay, so we can say that if the size will increase, so definitely capacitance is going to increase. Okay, so capacitor increases with the increase in size. What does the next point say? It says that it is dependent on the surrounding medium. How do I get to know that? Obviously, when epsilon naught is there, which tells you about the medium and its property, so definitely capacitance is dependent upon the medium also. So if the capacitance is to be talked in vacuum, then it is going to be 4 pi epsilon naught something, or maybe epsilon naught, on which it will depend on. And if you will speak about capacitance in a medium, then we'll take dielectric constant of that medium into account. Okay. Apart from that, yes, third point is the one which will set the basis of creation of capacitors or condensers. It is basically the presence of any other conductor body nearby. So it is practically seen that if you bring a charged body near any other uncharged conductor, then what happens? The polarization will happen. So the charge remains same, but the potential will decrease. And if the potential will decrease, then what will happen? By C equal to Q by V, if you want to increase the potential of a body, the if you want to increase the capacitance of a body, guys, then the one way is to increase the charge without letting the potential suffer or change, or by without changing the charge, if you are somehow able to decrease the potential, then also you can increase the capacity of a body. So mind you, we are actually still not saying that capacitance depends on potential. But what happens practically, say you already have a charged body, say this body already has some positive charge. If you bring a oppositely charged conductor nearby, so this is positively charged, this is negatively charged. When you bring two conductors together which are sharing or which are holding themselves two different or opposite polarity of charges, then the overall capacity of this combined arrangement is found to have increased. This is something which is what we say practically happens. So keeping all of these points in mind, we are going to create the new device which we call as the capacitor. Okay guys, please keep the third point in mind. Let me read it for you also. So if a charged conductor is placed near an uncharged conductor, its charge remains the same but the potential will decrease. As a result, the capacitance will increase, and that is what we are going to see when we are speaking about the different types of capacitors. Okay, so as we have just now talked about the capacitance, now when we are talking about the devices which we call as the capacitors, let's understand the definition first. So I'll read it out for you all. A capacitor is basically the combination of two oppositely charged conductors which are placed very close to each other but definitely not touching each other physically. It is used to store the electrostatic energy. That's basically the device which we call as the capacitor. Okay, so far you were talking about the idea of capacitance, which comes into existence as long as a body starts getting charge, its potential increases, hence it is storing some charge. But if you want to create a capacitor, or if you want to increase the capacity of already existing conductor, this is what we are going to do. We are going to place two oppositely charged conductors close to each other. So this will have positive and this will have negative potential. So the potential difference effectively will come out to be the numerical value which is less than that of an individual conductor. So because of which the value of potential will decrease or potential difference will decrease, which will result in increased capacitance comparative to a single conductor. So that is why the definition is very important, that a capacitor is going to be the combination of two oppositely charged conductors which are placed very close to each other. So if we say that capacitance is Q by V, now this V is nothing but the potential difference between A and B. And obviously A being positively charged, we assume that positive charge has more potential than the negative one. So that's why if we look at this VA minus VB, it's basically the potential difference between potential of A and B. Okay, so we'll use this idea, we'll take it forward and we'll try to find out the potentials of we'll try to find out the capacitance of three different types of capacitors. We are going to speak about parallel plate capacitor, spherical capacitor, and the cylindrical capacitor. As the name suggests, guys, these are the names which come for a capacitor body based upon the type of visibility or the appearance of that capacitor. Among these three, the most important capacitor that we need to study for our JEE or NEET preparation is basically a parallel plate capacitor. Okay, when various questions that we are going to solve in this chapter are obviously going to be based upon parallel plate capacitor, and that's why I'm going to derive the capacitance expression of parallel plate capacitor at the last. I'm going to start off with spherical capacitor and then the cylindrical capacitor. Okay, I hope the idea is clear in your mind, guys. The definition is how we are going to go, and we are going to find out the capacitance of these three capacitors. We'll speak about the potential difference. We'll speak about the charge which is stored on their body, and the ratio of that is what we are going to find eventually. So guys, let's start off with the spherical capacitor here. So what you see here, guys, we have an arrangement where we have two spherical bodies. This is just the half portion, or you can say the hemispherical part of the spherical capacitor that you are able to see here. So inner conductor is of the radius A and the outer conductor is of the radius B, and obviously the thickness is considered to be negligible. So say the inner one has been given some charge plus Q and the outer one is given charge minus Q. So definitely they have some potential difference, and we are interested in finding the capacitance, which is the capacitance of the arrangement of the two spherical capacitors, which are obviously of different size. Okay, they are obviously concentric as well. So guys, when we write the capacitance, we consider the charge on either of the capacitors and we divide it by the potential difference. So if I say that this is sphere A, so this is VA minus VB. Okay, so let's try to find out the potential of interior sphere, which has a charge capital small plus Q and outer one has minus Q. So potential of inner sphere due to its own charge is going to be KQ by A, and the potential due to outer sphere is going to be minus because it has negative charge, and KQ by B because inner sphere is an interior point for the outer sphere. Okay, and similarly if I try to write VB, so the potential due to inner sphere and the charge of that is going to be KQ by B, because for inner sphere the outer sphere is an exterior point, and because of its own charge it is going to be KQ by B only. So you can see that VB is nothing but 0. So when we are going to put these two potential values and their differences over here, the capacitance comes out to be Q divided by KQ by A minus KQ by B, and if I take KQ common, it is 1 by A minus 1 by B. So guys, what you see that Q gets cancelled, and 1 by K I can write as 4 pi epsilon naught, and this denominator can be written as B minus A divided by AB. So when this A into B goes in numerator, the final expression of capacitance for a spherical capacitor very simply comes out to be 4 pi epsilon naught A into B divided by B minus A. Okay, guys. So again, reiterating the fact that capacitance of any capacitor is not going to depend upon the value of the charge which is present over it, or the potential potential difference which the conductors have. Rather, it is always going to be in such ratio that the value of C is not going to change because of Q and delta V. Or rather, I would put it this way: if Q increases, delta V also increases. But what capacitance depends upon is what you can see here very clearly, that guys, capacitance of this arrangement is depending on the medium which is there between the two spheres and the physical dimensions of the spheres which we are using here. Okay, so I hope you have understood it. It's not very difficult. Okay, now moving on, let's speak about the cylindrical capacitor, guys. I would say the least important conductor capacitor with respect to your JEE preparation or even for your board examination as well. So here what we have as the name of the capacitor is cylindrical capacitor. So this is the side view and this is the top view of the capacitor. So it has two cylinders. The internal one has a radius A and the outer cylinder has a radius B. Say we are giving some positive charge to the inner cylinder and we are giving some negative charge. When I say some, it's obviously of the equal magnitude to the outer sphere, outer cylinder. Okay, so basically outer cylinder has minus Q charge and inner cylinder has plus Q charge. Okay, so say I consider the capacitance of this particular arrangement C, then obviously I'll have to find out the value of Q divided by VA minus VB. Okay, so if I look back from the linear charge arrangement, say if I define the linear charge density of this object as lambda, then we can write the charge on the capacitor or on the conductors also as lambda into L. So we'll see whichever form we are finding it comfortable to represent, we'll represent it either in terms of lambda or in terms of Q. Okay, so guys, when we are interested in finding the value of the potential difference between A and B, so unlike the previous case, here it will not be as straightforward as the previous one, because the electric field between A and B is something which is varying with point R, okay, or the location of the point, say point P, which is at a distance R over here. So if I consider a point P over here, which is say at a distance R, you can see it here. So if I want to write the value of potential difference VA minus VB, then obviously I'll have to find it by the basic relation between potential difference and electric field. So that is going to be integral of E dot dr. So say if I move from inner cylinder to the outer cylinder by dr amount every time, then the electric field over here is going to be 2k lambda by r into dr, and r will change from A to B. Okay, so here you can see that 2k is a constant, in fact lambda is a constant. Integral of 1 by r dr is what we are going to do when the integration limits are given from A to B. Okay guys, so if I integrate this, 1 upon r when integrate will come out to be ln r. So we can say that the value of VA minus VB is going to be 2k lambda ln r with limits changing from A to B. When I write this, it is going to become 2k lambda ln b minus ln a, or we can write it as ln b by a. So that's basically the value of the potential difference between a and b. So when we go back to the expression of capacitance, which is charge on any of the conductors divided by the potential difference VA minus VB, let me put the expression of VA minus VB. And because the expression of potential contains lambda, let me write Q as lambda L and divided by 2k lambda ln B by A. So you can see that lambda gets cancelled, and now if I try to simplify this, L is already there. This can be written as 2, and k 1 upon k can be written as 4 pi epsilon naught, and the denominator has 2 ln B by A. So from here, if I cancel this, final expression of capacitance for the cylindrical capacitor comes out to be 2 pi epsilon naught L divided by ln B by A, where B is the radius of the outer cylinder and A is the radius of the inner cylinder. Okay, guys, so this is how we found out the value of the capacitance of this capacitor, which came out to be 2 pi epsilon naught L divided by ln B by A. Okay, awesome, cool. Now everyone, coming to the most important capacitor, which we call as the parallel plate capacitor here. What you see here, that you have two plates. These are basically plates which are two-dimensional facing each other, something like this. These are two plates facing each other, and their inner surfaces are charged in such a way that this plate has charge positive Q, the other one has charge negative Q, and the electric field is obviously from positive to negative plate. Say the separation between the two plates is D. So if I try to write the value of capacitance, obviously it is charge of one of the conductors divided by V, let's call it A, and let's call it B. So this is going to be VA minus VB. Okay guys, now when we are interested in writing this value, let me just write it as Q by V here. So the value of charge, assuming that the charge density is sigma and minus sigma, we can write the charge as sigma into A, because A is the area of the plate, divided by V. Now how do I write the value of V? Because you know that the capacitor, the value of the electric field because of a conducting plate is a constant, and that value for single plate is sigma upon 2 epsilon naught. Because there are two plates which are facing each other, the electric field between the two plates is going to become sigma upon epsilon naught. So the value of potential, because electric field is constant, is going to be E into the gap between the two plates. So this value becomes sigma D upon epsilon naught. So let's do one thing. Let's put the expression of V here. Capacitance of the parallel plate capacitor looks like it's going to be sigma A divided by sigma D into epsilon naught. So sigma gets cancelled, and the value or the expression of capacitance comes out to be A epsilon naught by D, which is, I would say, is the most important expression in terms of the three capacitors that we have talked about so far, where A is the plate area of each plate, epsilon naught is the permittivity of free space, and D is the separation between the two plates. If the medium is going to change, then the capacitance will become A epsilon by D. Okay, this will be valid for any capacitor. When the medium will change, we'll replace epsilon naught as epsilon. Okay. Also, the symbol of this capacitor is very important for you to see. Is represented like this, like two parallel lines, and they will become a part of a capacitive circuit. We are going to obviously see a lot of capacitive circuit when we are going to get into the discussion of current after this. Okay guys, so a quick recap for all of you. When we are talking about different types of capacitor, the idea of capacitance is this, that whenever we are finding the value of the capacitance of a capacitor, it's basically going to be found by bringing two conductors nearby to each other, giving them equal and opposite charge, which will make sure that their potential is less than the individual potential. And that is why when we are talking about the different types of capacitors, the same idea has been used. And the capacitance of the first one, which was spherical capacitor, came out to be 4 pi epsilon naught AB by B minus A. For the second one, which is cylindrical capacitor, came out to be 2 pi epsilon naught L divided by ln B by A. And the most important one is the third one, which we call as the parallel plate capacitor. As the name suggests, these are two parallel plates facing each other having opposite charge. The expression of capacitance comes out to be A epsilon naught by D. Okay guys, so these are the expressions which are very important for us to keep in mind. Definitely in the next few sessions we are going to solve problems also related to capacitance, and we'll get into the more depth of this chapter as well. Okay, so this brings us to the end of the theory discussion today. But guys, as I told you all, there is a big reveal which is coming up for all of you guys, and just 2 more days and you are going to get the updates on our app. That update is something for which you have to either download the app if you have not downloaded it yet, or if you have already downloaded the app, you have been using it, then guys, do update your app so that you are able to receive the news of the big reveal that Vedantu is coming up with. Okay. Also, if you are a student who is aspiring for JEE 2020, you know that your JEE examination is round the clock. So, guys, we have a crash course which is running specifically for you guys who are targeting JEE 2020. This crash course has already begun from 11th of May this month, and a lot of live lectures are going on there. Students are appearing for test series over there whose analysis and paper discussions happen every alternate day. A lot of rank booster quizzes happens during the lecture, and a lot of things are being shared with you guys. So if you are a student who is aspiring for JEE 2020 and are very serious but are worried because of the lockdown you are not able to go out and study, so guys, this is an opportunity to make sure that your JEE dream does not just remain dream, it becomes reality. So if you are interested in that, then guys, all you have to do is a link which I'm going to show you. On that link you have to go and use the code SMCC, because when you will use this code, the course which is actually worth rupees under 25,000 can be yours for just rupees 6,000. Okay guys, let me show you how that actually works. So if you will go on the description of any video over here, you will find that the link for crash course is in the description. So if you will click here guys, you will be directed to a page over here, and on that page you have to click. So when you will click, you have to just put the coupon code here. What is the coupon code? SMCC. Once you apply this coupon code, the coupon code will give you further discount for rupees 2,000. Okay guys, so the course which is actually worth rupees 25,000 can be yours for just under 6,000 rupees. And if you want to see how exactly the Vedantu platform looks like, then guys, let me show you that as well. So this is how real time your Vedantu login looks like. This is the timetable of the crash course. Say if I speak about any of the days here, so say 23rd, if I click here, you are going to have a lecture at say 4 o'clock. You had a lecture with Aditya sir, and similarly all of your lectures are visible here. You can see that guys. Okay, so basically if you are a person who does not want to waste time in making the timetables, or rather you make timetables but you end up not following it, then this is a forced routine which we are helping you out with. So you just have to follow, and your entire JEE preparation gets taken care of. Let me also show you the content which is available for you. An amazing content library is there. So see, this is the course that you get actively involved in. Say I'll show you the content which is there for physics. So see, as the course is progressing, the amount of content and the tests are also increased here. So say if I show you this, then you can attempt any of these assignments, and when you take the assignments, guys, this actually gives you the simulation exactly the way JEE examination is. You can see the list of all the questions. You want to jump from any question to any one, you can do that. If you want to answer it, you can go to the next one, you can skip as well, you can select, you can deselect, you can move from one question to another, and once you are done, you can end it. So basically, it is something which gives you your feel for actual JEE examination, and that is what I believe is very crucial. It is like doing net practice before playing the actual match, and unless you do the net practice, guys, definitely the actual performance in the match will lack something. Yeah, not just that, guys, also you can see that a lot of study materials are also there. So if you click here, then you will be directed to the content which you can solve by yourself, or you can study theory as well. You can see that a lot of questions from previous year examinations are also given over there. So all in all, what I'm trying to tell you all, guys, is that if you are a student who's aspiring for JEE 2020, that means if you are appearing for this examination in the month of July 2020, and you can still count, guys, this is almost towards the last week of May, and after this you have entire month of June and almost 15 days of July. So I say that you still have a good amount of time to give your preparation your final boost. So if you think this is going to be helpful, then these are the steps that I've already told you. Go to that link which is available in the description of this video. Click on the coupon which I have told you, which you have to use is SMCC, and then just enroll now. Click over here. You will become the part of this crash course. Okay? So if you want, you can definitely. The learning on YouTube channel is happening. That's free of cost, no doubt about that. Okay, cool. Also, if you are a student who's going to appear for JEE 2021 and you have missed a few lectures that I have conducted already for electrostatics and Gauss's law, all you have to do is look for the playlist on Vedantu's JEE channel. You will find all the previous lectures that I have done on electrostatics, because that's the very first chapter in 12th standard. Okay. Also, guys, if you are interested, you can come on our Telegram group as well. And on the Telegram group, guys, we provide you assignments, study material, and daily updates. How do I join Telegram group? The link for that is also available in the description of this video. Okay, so do come there. And if you enjoyed starting this session with me for capacitors, then do press the like button, guys. Share with your friends, let them also study along with you. And if you have not done it yet, as I always say, subscribe to the channel and press the bell icon so that you are always notified whenever I am coming live or your other master teachers are coming live. So guys, with the promise that even when difficult times are running, your learning won't stop. This session comes to an end. I will see you again with another interesting session of capacitors, and furthermore we'll continue this journey of our JEE preparation. Till then, keep studying, keep enjoying physics. Yes, more importantly, keep smiling, and much more importantly, stay safe. Bye bye, guys. I'll see you soon.